Good day, everyone. My name is Mr. Adewujimi Adedoso. What we're looking at is trigonometry. Trigonometry. Under trigonometry, what we're looking at under this, we'll be looking at Pythagoras Theorem. We'll be looking at Pythagoras Theorem, which is also known as Pythagoras Theorem. We'll be looking at proof of some special angles. We're looking at proof of some special angles. Before this, let me just introduce you to let's just look at the Pythagoras Theorem. Let's look at Pythagoras Theorem. What does Pythagoras Theorem state? Pythagoras Theorem states that in a right angle triangle, the square of the longest side, that is the hypotenuse, must be equal to sum of the square of other two sides. Or you call it Pythagoras. Pythagoras. Okay? Chinese call this Gogu and not Pythagoras. Okay? Let's go. This is a right angle. Is this a right angle triangle? This is not a right angle triangle. This is not a right angle triangle. Why? Because there's nothing to indicate here that this is a right angle triangle. But if I have this to it now, this is a right angle triangle. Yes. So let's call this to be A, B, and C. Okay? The right angle is at C. The right angle is at C. So this is 90 degrees. This is a perpendicular line. Are we together now? So this is the hypotenuse. This is the hypotenuse. This is depending if you want our angle to be here. If you want our angle to be here, it means that this will serve as the opposite to this angle. If you want our angle to be here, this will serve as the opposite to this angle. So where two straight lines meet at the point, angle will be formed there. So we can have our angle to be here or here. Okay? But let's assume that we're having an angle here to be angle alpha. Is that also? So where alpha is facing will serve as the opposite of this triangle. And this will serve as what? The adjacent. That's the adjacent to this triangle. Okay? Hypotenuse, the longest side, opposite the what? Where the angle is facing, that is what the opposite. While where this is facing is the adjacent. So normally you can put it this way: where this angle is facing is always what? Hypotenuse. Either you have it facing this way, or you can also have it like this. Okay? If this is facing this, so this will be the hypotenuse. You can see that this is quite different from this. But this is the same thing. This is the right angle triangle, while this is also what? Right angle triangle. And what does this Pythagoras theorem state? The Pythagoras theorem states that in a right angle triangle, the square of the longest side must be equal to sum of the square of other two sides. That is to sum of the square of these two sides, the square of this side. So let's go. Okay? We have this to be A, B, and this is C. This is alpha, right? So where is this B facing? The B is facing the what? This adjacent. So that will be small b. Where is this A facing? The A is facing this side. That will be small a. This will be small what? Small c. Are we together? So using what? Pythagoras rule now. Using Pythagoras rule. Using Pythagoras rule, we can have let AB squared equals to let BC squared plus let what? AC, actual congress. So what's AB? Abraham is what? C squared equals to, what about BC? BC is what? A squared plus, what about AC? Actual congress is what? Is B squared. So let's call this to be asterisk 1. Okay? So from here also, using trig identity, from our trig identity, we know that, from our trig, we know that we have so, ha, and 12. Okay? these are the three that we have. But we still have more than this. We have sines, we have sines, we have cos, we have tans. Okay, this is bit what advanced. Okay, but for our level, we'll be looking at SOHCAHTOA, that is sine, cosine, and tangent. When you say sine, that is opposite over hypotenuse, When you say adjacent over hypotenuse. Okay, when you say tan, that is tangent, that will be opposite over what? Over adjacent. Are we together? Okay, so we're looking at this triangle. Okay, from here we can have opposite of hypotenuse. That will be what? Sine alpha equals to opposite, that is A over what? Over B. That's opposite over hypotenuse, that is A over C. Opposite over hypotenuse, A over C. Second one, we have cos alpha. Cos is car. That's adjacent over hypotenuse. That will be adjacent. This is the adjacent to this and adjacent over hypotenuse. That is B over C. Okay? The third one is tan. That is tangent. Tan alpha will be equals to what? 12. That is opposite. Opposite over adjacent. That is A over B. Okay? Now we also have what? Another what? Trig like cosec theta. Okay, because of this alpha, let's call it cosec alpha. We have what? We have sec alpha. We have what? We have cot alpha. Okay? Okay? So look at this. Cosec alpha. What's cosec alpha? This is derived from where? From this. Cosec alpha, my teacher said I'm going to count 3 letters. Just 3 letters. Now let's start counting. 1, 2, 3. This is the third letter, which is S. That S stands for what? For sine. So what would be cosec? That would be inverse of sine. So inverse of sine is sec. Inverse of sine is sec. That would be 1 over sine. 1 over sine. So that would be 1 over A over C. That is 1 over A over C. And what would that mean? That would become what? C over A. Are we together? So what about sec 2? You count 3. 1, 2, 3. The third one is C, which is cosine. That is 1 over cosine. That will be C over B. That's C over B. So the last one on the list is cot. That is cot 1 over T. 1, 2, 3. You always count 3. So 1 over T. T there is tan. That is 1 over tan. And our tan is A over B. So that will be B over C. Okay? So from here now, let's go. So we have C squared equals to A squared plus B squared. We call this asterisk 1. This is gotten from where? From Pythagoras Theorem or Pythagoras Theorem. So this is Pythagoras true. So let's go for that. So C now, we can say divide through by C squared. That's the rule. You divide by what? By the first letter here. Divide through by C squared. Meaning that we have it C squared divided by C squared equals to A squared divided by C squared plus B squared divided by C squared. This will give us 1 equals to, this is still the same thing as A over C all squared plus B over C all squared. Okay? Now recall that A over C is sine alpha. A over C is sine alpha. So we can have 1 equals 2. A over C, that's sine alpha. So that will be sine square alpha. Okay? Sine square alpha plus B over C. B B over C, that's cos alpha, that will be cos square alpha. So therefore, we can have sine square alpha plus cos square alpha equals 1. This is the false identity. Okay? So let's look at the second one. The second one. Okay? So let's look at the second identity. So the first time we divided through by what? By c squared. So this time around, we move to the second part, which is a squared. So we're going to write divide through by what? By a raised to power 2. So we have c squared divided by a squared equals to a squared divided by a squared plus what? Plus b squared divided by a squared. They have to have the same denominator. Okay? This and this will go. Okay, that will be c over a, or what? Or squared equals to 1. This will give us 1 plus b over a, everything raised to power 2. What's c over a? C over a is cosec. So that will be cosec square alpha equals to 1 plus, what's b over a? B over a. Where do you have b over a? Oh, sorry, this will be b over a, cot 1 over tan. So 1 over this will be b over a. So that is cot square alpha. Okay, this is the second identity. Take note, this is the first one and that's the second one. So let's look at the third one now. The third one, we can look at the third one, okay, by dividing through, divide through by what? By b squared. The first time we divided through by this, and the last one is this. Okay? So we're going to have what? C squared divided by what? Divided by b squared equals to a squared divided by b squared plus b squared divided by b squared. So this will be c over b, all raised to the power of 2 equals to a over b, all raised to the power of 2 plus 1. Okay? Plus 1. So what's c over b? What's c over b? C over b is sec. That is sec square alpha. C over b is sec square alpha plus a over b. A over b is what? Tan. That's tan what? Tan square alpha equals to tan square alpha plus 1. So this is the third identity. Please take note, please. So let's look at this example. The diagram above. Find the value of x. Okay? The diagram above. Find the value of x. How do we get the value of x? We can only get the value of x using Gauss's theorem. Generally known as Pythagoras Theorem. Okay? Which says that what? In a right-hand triangle, the square of the longest side must be equal to sum of the square of other two sides. Meaning that Abraham squared must be equals to BC squared plus what? AC, that is actual congress squared. What is Abraham? Abraham is 5, that is 5 raised to the power of 2. What about BC? BC is 4 raised to the power 2. What about actual congress? Actual congress is S squared, that is AC. Okay? So this will give us what? We can simply write this as 4 squared plus S squared equals to 5 squared. Are we together? So what is 4 raised to the power 2? That is 4 times 4. And that's 16 plus S squared equals 20 what? 25. Okay? So you can collect the like times. X squared equals to 25 minus 16. So x squared equals to 9. Are we together? So you have to be very, very careful of this. Once you get here, you know, if you have to do it, normally you say x equals to square root of 9, and which is equal to 3. It is wrong. This is totally what? Rubbish. I call it rubbish. So what would this be now? We can say x equals to, okay, plus or minus, take note, square root of 9. So you can say x equals to plus or minus 3. But it's not possible for x, that is for the length AC, to be negative. Do you understand? It's not possible for this length to be negative. Just like you want to measure the length AC using your what? Your meter rule or your measuring instrument, it is not what possible for you to be getting the distance or the length to be minus. We know that. So we can say therefore x equals to plus what? Plus 3. So that's the value of x. So this will be the value of x, which we are asked to what? To look for. Let's move further again. Let's go a bit further. Let's move a bit further. Now let's go. Example 2. Example 2. If sine theta equals to 4 upon 5. If sine theta equals to 4 upon 5, find the following. Find the following. Find the following. A cos theta. B tan theta. C cot theta. D sec theta. E cosec theta. Okay, let's look at it. If sine theta equals to 4 over 5, find the following. A cos theta, tan theta, cot theta, sec theta, cosec theta. Let's quickly tidy this up. Pretty simple. But normally this is, I'm going to give you two methods now to get this. I'll give you two methods on how to get this or everything. So two methods, can decide to pick anyone you want. But I advise you to master the two methods, okay? Now let's go. Solution. We are given that, given that what? The sine theta equals 4 over 5, isn't it? Alright? Then we know that since this is sine theta and sine theta is 4 over 5, what are we asked to find? We asked to find cos theta. Then we know the trick, the trigonometry, that combines sine and cosine together. And what is that? That was what the first trick that I proved, the one that I deduced, the first one, which is we can say recall. That's the name of my guy. Sine square alpha plus cos square alpha equals to 1. You remember this? Recall. If you're writing y, it's very, very important to write this. That is half mark. That is half mark. The formula half mark. Very, very important. Okay. Now let's go. We'll be giving sine alpha. Okay. If you have sine square alpha, that is sine square alpha. You see the same thing as sine alpha. To the power of 2. Are we together? Now let's go. So this is still the same thing as this. Is that true? And we have been giving this to be this. So that will be 4 over 5. All raised to the power 2 plus. We have to look for cos this. So this is cos square theta. That's what we have to find. Cos theta. So equals to 1. So we can have cos what? Cos square theta equals to 1 minus 4 upon 5 all raised to the power of 2, and that will give us 1 minus 4 raised to the power 2, that's 16, 5 raised to the power 2, that's 25. This is still the same thing as super 1. You look for the lowest common multiple, that's the LCM. The LCM of 1 and 25 is 25. How many times we want go go in 25 times 4, that is 25 minus 25 1 times 16, that gives what? 9 upon 25. So we can say cos theta equals to plus or minus square root of what? 9 upon 25. That gives 3 plus or minus 3 over what? Over 5. Therefore, cos theta equals to 3 upon 5. That's the first part. Now let's go. Alita, or let me just write method 2. Well, alita means method 2, alternative. In order not to confuse you, alita means alternative, okay? For some textbook, they use alita, but generally they use alternative or method 2. So let me just write it as method 2. Now, you can also do it this way by drawing a right angle triangle, okay? Draw your right angle triangle. Draw your right angle triangle. This is your right angle triangle, isn't it? This is theta, okay? We are given sine theta. Sine theta, that is opposite and hypotenuse. So this is the opposite to this angle. This is hypotenuse. Where this is facing, that's the hypotenuse, which is 5, okay? With the help of what? Of Gauguin theorem. So you get this side to be 3. Okay, this will be 3. And what are we asked to find? We want to find cos theta. Cos will be car, that's car. Adjacent over hypotenuse. So A, you can say cos theta equals to adjacent 3 upon 5. You can see that this is still the same to that this. Okay, B. We want to look for tan theta. Tan is toa, that is toa. Toa, that is opposite over adjacent, that is 4 over 3. That's tan theta. Tan theta equals to opposite over adjacent, that's 4 over 3. So the next one now, that's C. Cot theta. Cot theta. What's cot theta? Cos theta, we can write this in so many forms. Okay, this can be written as 1 over tan theta, take root of that, which is still the same thing as cos theta over sine theta. This is still the same thing as this. Why this is the same thing as this, okay? Note, notably, that what? That tan theta is sine theta over cos theta. Note this, please, note. But cos theta is cos over sine, okay? The inverse of this. So this will move on, this will move down. Okay, so we can have it now to be cos theta to be equals to sine, cos over sine. That is cos theta over sine theta, or we use 1 over this. So that will be, we have our tan theta already to be 4 over 3. So that will be 1 over 4 over 3. So when you have something like this will move up, the 3 will move up, that's this. This will move up. To multiply that one, that will be 1 times 3 over 4. That is 3 over 4. Okay? Or if you don't do it like that way, you can say this over this. Okay? To still give you the same answer. Let's go. That's the answer. Okay? That's cos theta equals to that. Method 2. Method 2, we know that was C. We know that cot theta equals to what? Equals to cos theta over sine what? Sine theta, which is equals to what's cos theta? Cos theta is 3 over 5. That's 3 over 5 divided by sine theta. That's what? 4 upon what? Upon 5. Okay? Normally, if you look at the LCM, this and this, they are the same. You can cancel out. But I will not want you to do it that way. Okay? You can do this with 3 over 5. This is long division. It can also be written as 4 over 5. Can you see that? 3 over 5 is divided by this. And we know the rule. In order to change this to multiplication, the numerator will become what? The denominator. While the denominator will become the numerator. That becomes 3 upon 5 times 5 upon what? Upon 4. this guy and this guy will go. So after we keep on, so we left with 3 over 4. So you can see therefore cot what? Cot theta equals to what? Equals to 3 over 4. Still the same thing. So the last general pronoun is, oh, not the last, D. You can pause the video and try this. So sec theta, sec theta. So what's sec theta? 1, 2, 3. The third letter there is cos. So that will be 1 over cos theta, which is equals to 1 over, we have already solved for what? For cos theta. That is 3 upon 5. And that will be 5 upon 3. So E now, we want to look for cosec theta. Cosec theta. Cosec theta will be, count 3, also 3 letters, 1, 2, 3. So the third one, that will be 1 over sine what? Sine theta, which is equal to 1 over, what sine theta? Sine theta is what? 4 over 5. That's 4 over 5. Inverse of 4 over 5, you take this guy up, that becomes 5 times 1 over what? Over 4. That is 5 over 4. Thank you and God bless you.